Hello one and all. Today we are going to discuss the soil mechanics chapter and the detailed explanation as well as problem also we will discuss. And unlike other channel, I will not skip anything. We will continue going as per what studying, everything will be there. So continuously please watch the channel and watch all the videos till the end. So let us the geotechnical engineering topic. In that it is divided into two, soil mechanics as well as foundation. So first we will start with soil mechanics. So this is the detailed syllabus of soil mechanics. So when you watch all my videos, when the starting time, I will show all the detailed syllabus of each session. So soil mechanics, so we will study here these all topics: three-phase system, phase relationship, index property, unified and IS soil classification, permeability ID flow, permeability 1D flow, seepage 2 soils 2D flow, flow net, uplift pressure, piping capillarity, seepage force, principle of effective stress and quicksand condition, compaction 1D consolidation and time rate of consolidation, shear strength and Mohs circle, effective and total shear strength parameters, stress strain characteristics of clays and sand, and last stress packs. These all are the portions of GATE syllabus. I said na, so many portions have removed from the GATE 2021, as well as so many nice portions they have added also for covering all the various aspects of the geotechnical engineering topic. So let's start with soil mechanics. So first we will study here three-phase system and the phase relationships. So what is actually soil? Soil can be called soil as solid, can we call it as gas, can we call it as liquid? We cannot call it as separately, because soil, it is composed of all the three things, and these three components compose to form three-phase system of soil. So this is a system. So we can see here, these are the grains, or we can call it as the solid. And the vacant spaces, this vacant spaces you can call it as voids. Okay, so solid is already equipped here in a part of the soil, but we can see here void, that means additional spaces here in between the solid. That void can compose of air as well as liquid. If fully it is composed of liquid, we can call the soil as fully saturated soil. That you know. That means it is fully composed of water only. If half liquid and half air, we can call it as partially saturated soil. If fully composed of air, what we will call it as? It is a dry soil. Okay, so depending upon the changes with the amount of water content, depends upon changes of amount of water content, we can differentiate soil into these three parts, that is fully saturated, partially saturated, as well as dry soil. So this is the first thing we have to learn from the three-phase system actually. It is air, it is water, and this is soil solids. That means grains. Okay. So in air portion, what is the water? In the air portion, the weight of air, we are considering weight of air as very zero because it is a very negligible value. And in water portion, we consider it as WW. And soil solid portion, the weight is considered as WS. That all you know. And here, the volume of air. And here in case of water we call volume of water, and this is volume of soil solids. And together now we have studied what all portions composed of our void. These two portions, that means air and water, will composed of volume of void. Same way we can say that this much portion mass of air, this much portion mass of water, and this much portion mass of soil solid. So likewise we have just now said na, if the three-phase system became two-phase system, that means fully it is composed of water half and the balance is solid. We can call that system as what I said. It is fully saturated. And if the half portion is composed of air and no water and it is composed of solid, we can call it as a dry soil. And this system we can call it as half air and half water as well as soil solid. We can call it as partially saturated soil. So by this we have understood that the volume of void is called the volume of air plus volume of water. This is very, very important. Now we will learn the basic definitions. First is the void ratio. We can call void ratio as E. Okay. So void ratio will be the total volume of voids by the volume of solids. Just now we have studied na. This together will composed of volume of void and this is composed of volume of solid. So this ratio totally directly will be the void ratio, that is VV by VS. This will be the void ratio. Next is porosity. We will learn the relationship between void ratio and porosity afterward. Now we can learn what is actually that. And if I am talking about porosity, we will consider the total volume also. Okay, so here what is the definition? Total volume of void by the total volume of the soil actually, that is VV by V. Understood? So here we are considering, we are taking the ratio of VV by VS. Here we are taking the ratio of VV by V. That is the difference between void ratio and porosity. Now, next is degree of saturation. We can call it as SR or directly S also, no problem. SR or S. It is the volume of water and volume of void ratio. Okay. We said that this is the volume of void totally. That means this is composed of air and this is water. So how much water? This is the volume of water and this is the volume of air. So the ratio of volume of water to the total volume of void, VW by V. This is called a degree of saturation. So tell me what was the S or degree of saturation for fully saturated soil. Fully saturated means it is totally composed of this air and water, fully composed of water only. So we can call it as VW by VW. So fully saturated, degree of saturation will be what? 1. For dry soil, in case of dry soil means no water is there. So VW value will be 0. So SR also will be what? 0. So these are the important questions. It can be asked in MPSC examinations also. Next is air content. AC. So same way, we now degree of saturation means how much water in volume of void. Same way we are taking here volume of air. That means the volume of air by inside the volume of void. Very easy. We can compare and study. It will be easy. Saturation means volume of water by volume of void, as well as air content means volume of air by volume of void. And we should know this air and water are correlated. So we can say that air content will be 1 minus saturation, or saturation will be 1 minus air content. These all will be studying in the comparison. Don't worry, we will study there. Last percentage air void, that is mu A. So what is that? Here we are considering the total volume. So percentage air void means how much is the volume of air by the total volume of. So, and as it is percentage, we have to put the total volume, water content or moisture content. Abbreviation is small w. It is the weight of water by the weight of dry soil solid. That is WW by WS into 100. It is in percentage value, because every time it will be getting in 5%, 6%, 20% like that. So it is WW by WS into 100. Next one is bulk density. You know what is density? It is represented by gamma. Density is what? Weight by volume. It is bulk density. If it is dry density, what will happen? It will be gamma D, and it is weight of this dry soil solid by total volume. If it is density of solid, it will be gamma S. So it will be density of weight of this dry soil solid in the volume of this soil solid. This is a difference between dry density. Dry density means same way, weight of the dry soil. Here also we are considering weight of dry soil solid, but the ratio will be different. Dry density means from the total volume, but density of solid, it will be from the ratio of the volume of solid ratio. Next is saturated density of soil, that is gamma saturated. So every time it will be ratio of weight by volume, weight of saturated soil by the total volume. And next is submerged density. Submerged density, it will be gamma. Submerged is weight of dry soil which is submerged by the total volume. Weight of the dry soil solid which is submerged by the total volume. And gamma submerged is equal to gamma saturated minus gamma W. This is most important. What is submerged will be the difference between gamma saturated minus gamma W. And every time you have to understand, rho W value will be 1 gram per centimeter cube cc, and gamma W value will be 9.81 kilonewton per meter cube. This is very, very important in terms of calculations. Then the last one is specific gravity of soil solid. Specific gravity of soil solids, G. It will be the ratio of gamma S and gamma W. And bulk or apparent specific gravity. it is Gm. So Gm will be gamma by gamma W. Every time this bulk specific gravity or apparent specific gravity will be less than the specific gravity of soil solid, and this Gm value, it is not a constant value, it will change. So specific gravity, there is a definition: ratio of the weight of the given volume of soil solid and the weight of an equal volume of distilled water at given temperature 27 degrees Celsius, both weight being taken in air. So this is the general equation for the calculation purpose. So I hope everybody enjoyed and liked the session. So if you like the session, please click the like button, and if you have any suggestions, please put in the comment box. And if you are watching my channel for the first time and if you haven't subscribed it, please subscribe and click the bell icon for getting the upcoming notifications. Tomorrow we will deal with the rest portion, functional relationships and the related problems tomorrow. Have a